The nitrogen cycle. Big picture. Nitrogen is an extremely important element on Earth in our atmosphere. Nitrogen is a component of proteins and nucleic acids and is used for the growth and development of living things. Approximately 78% of our atmosphere is made up of nitrogen, but the biggest issue is that although there is a lot of nitrogen gas, the majority of this reservoir is unusable by most organisms. As a result, nitrogen gas goes through a multi-step process that allows for all living things to use nitrogen, and this is referred to as the nitrogen cycle. To define the nitrogen cycle, it's the movement of nitrogen around the biosphere from sources to sinks. The nitrogen exists in the elements as an inorganic molecular compound, but throughout the cycle that can change. The main facilitators of the nitrogen cycle are bacteria within the roots of plants, but abiotic factors can also play a role as well, such as combustion. So we're going to go into depth about the process of the nitrogen cycle. Nitrogen gas starts out in the atmosphere as an inorganic form, but at this point it is not accessible to the majority of living organisms. So the first step is through a process known as nitrogen fixation. The nitrogen gas in the atmosphere is converted into a form of nitrogen that can be used by producers. And there are two ways of facilitating this action. The first way is through a biotic process. In this process, bacteria or cyanobacteria that live in the roots of plants such as legumes convert the inorganic nitrogen in the atmosphere into ammonia, and then into ammonium. The other way is through the abiotic process. In this process, a combustion needs to occur, whether it's burning fossil fuels or through a fire. In the combustion process, nitrogen gas in the atmosphere is converted into nitrogen, which is usable by plants. Either way, usable nitrogen is existing in the plants at this point in the cycle. Secondly, the ammonium ions produced by aquatic cyanobacteria are excreted into the water, whether it's like a lake or a river or like a body of water. And then it's taken up by aquatic producers or plants. Also, bacteria within the land plant roots excrete ammonium as well into the plant root systems, and the plant will supply the bacteria with sugar it produced during photosynthesis. Thirdly, a process referred to as nitrification occurs, and this is when ammonium is converted into nitrate and furthermore converted into nitrite. This process is conducted by specialized bacteria. Fourthly, after the nitrogen has taken the form of either ammonia, ammonium, nitrate, or nitrite, the producer will incorporate these elements into their tissues. Now, when a consumer comes into contact with the producer's nitrogen will assimilate into the tissues of the consumer, while the rest of it is recycled as waste. A good real-world example of this is when it rains, the plant will absorb the nitrogen through its roots, and after fixation and assimilation, let's say a cute bunny walks by and happens to be hungry, the bunny will eat the plant, although a plant along with the nitrogen within it. Fifthly, eventually animals die, including that cute bunny that we were referring to. After the organism dies, the fungal bacteria decomposers will break down the organic matter found in the corpse, and they'll break it down into inorganic compounds such as ammonium, nitrate, or nitrite. And then lastly, after the consumer's body is decomposed and the organic matter is converted into nitrate, it is then converted into nitrous oxide and finally nitrogen gas, where it can be emitted back into the atmosphere, which is, the process is conducted by specialized bacteria that live under conditions such as waterlogged soils or bottom sediments. Sorry. I don't know why that happened. For human impacts on the nitrogen cycle, as I said before, nitrogen is a limited nutrient, which means many species that adapted to limited amounts of it. Most of the reservoirs in which nitrogen compounds occur in the nitrogen cycle hold these compounds for a relatively short amount of time. So, these organisms are already well adjusted to it not being around for that long or having limited amounts of it. And as a result, too much nitrogen can have serious impacts on the environment. One of the biggest culprits is runoffs of fertilizers and livestock waste, both which lead to excess amount of nitrogen in the aquatic ecosystems, which eventually lead to eutrophication, I think which is when there is a dense growth of plant life and death of animal life because of the lack of oxygen. Adding nitrogen to soils and fertilizers increases the amount of nitrogen in the atmosphere, and as a result, the excess nitrogen comes down in rainfall in places where it really doesn't need more nitrogen. Through a process known as leaching, dissolved molecules are transported through soil via groundwater after it rains, and the influx of nitrogen has allowed for colonization of new species that are adapted to soils with higher concentrations of nitrogen. And with this, there are significant changes in biodiversity and with movement of energy through these ecosystems. Some of it isn't always just about fertilizers. It also can be a result of like combustion of gasoline or other fossil fuels. This releases a chemical compound known as NOx, which is an ingredient needed for the formation of harmful ozone, also known as photochemical smog. In conclusion, an increase in nitrogen is harmful to the environment as it can disrupt the biodiversity of an ecosystem and kills off other species, as well as releases photochemical smog, as I said before.